So first of all, thank you for the invitation, and let me introduce myself first. So I'm Ákos Hamar from Vico Software, and actually I'm coming from Hungary this time. To really introduce myself, I made my studies in Hungary. I'm an architect by my degree, and I joined Vico in the very early ages. I joined actually when it was not even Vico, but Graphisoft, and I think I did everything that someone can do in the building information modeling services side. So I started as a modeler, then I became a project manager, and I traveled to the United States. I worked there for 2 years on different constructions and studied building information modeling in actual use. Then I came back to Budapest, Hungary, and I'm now responsible for all our modeling activities in Hungary. Let's see the agenda. I'm going to introduce Vico. I don't know how much you know about Vico software, so I'm going to spend some time on introducing Vico. Even though it's not going to be a software introduction or it's not going to be a software training, I do have to do some brief introduction in order to understand the second part of the agenda, which is going to be about how we can manage the flow of information and the huge amount of data that we are going to get from the building information model. So about the introduction, as I said, even myself, I joined Vico when it was not Vico, so you can now see that it started out from Graphisoft in 2004, and that's when we invented the 5D virtual construction. And at certain business decisions, in 2007, Vico formed its own company, and from 2007, it's an independent company. It grew as big as it could, so it's globally all over the world. We are happy to have customers from Brazil to Australia, Japan, and obviously our biggest market nowadays is the United States, because we found that they are the fastest, the general contractors and owners are the fastest in the United States to implement new technology. But now we can see, especially Scandinavia, the Nordic countries, that they are getting up to speed and they are really fast in implementing the applications nowadays. From the AEC, architecture, engineering, and construction, Vico is focusing on construction. We believe that's even though it's in a building life cycle, that's only a small portion, but it gives us enough tasks for the upcoming few years to develop solutions as well as services to solve any kind of issues that may occur on real constructions. And the latest news that I have to add to this introduction is that just last Friday, on 2nd of November, if I'm right, the company was bought by Trimble. So actually now we are in the same family with Tekla, and that was the recent, I think, last year purchase for Trimble. And also SketchUp, for example, that's the part of the family. So we are really excited about this third chapter of Vico, and we do believe that it will make BIM or grow BIM faster and bigger, hopefully. Going on with the introduction, Vico Software, as the name says, it's a software company. So there is no surprise that we have a huge department of software development. But it might be surprising that we have professional construction services as well. And because I'm coming from this services side, I would like to talk a few minutes about it. And I also do that because I would like to introduce a couple of ideas how building information modeling can really be used on site, on real constructions. So let's start with 3D modeling. That's the most obvious when we talk about building information modeling, but as in the previous presentations we heard, don't think that a model means only the 3D model. That's just the basis, that's just how we start, and we will add more and more information to our model. So obviously the I in the BIM abbreviation stands for information. The more we add to it, the better results we can get in the end of the exercise. So during 3D modeling, we also perform constructability analysis. It means that we are really doing the same as the field guys would be doing on site. We have the luxury not to be in the rain, in the water, and doing it in the dirt, but in warm computer rooms. And we are building the 3D models from 2D documents, pretty much. And we are actually using the same documents as the field guys would be using. So we are not even cheating. We are not using DWGs because we could measure something from it, or we could snap to certain points in the DWGs, and we just don't want to do that because the field guys cannot do that either. And while we are building these 3D models, we find missing pieces of information and contradicting information, huge mistakes, to be honest. And we just document all these and then send to our customers, to our clients, so they can analyze what to do. They can send it to the referring designers to solve the given issues. Once we have the good models, we can go on to scheduling and estimating. I'm not going to spend too much time on this this time because I have a couple of slides later on about it. Let's see a couple of images as well while I talk. Because, for example, the next bulletin point is MEP lean coordination. To BIM, the entry point, especially in the United States, is MEP coordination. That's the lowest hanging fruit in some cases. And we see that many of the customers, many of the general contractors and owners like doing coordination, MEP coordination, 3D coordination. We found out a better way, we believe. I'm not going to detail it too much out now, but it's not a clash detection anymore. It's rather clash avoidance, as you mentioned. And we are not trying to solve the issues that we generated by, let's say, a bad design or bad modeling techniques. We just wanted to avoid them as we go. In the end of this exercise, we usually create such 2D layout drawings. We give it to the subcontractors, and that's again an answer about responsibility. Still, the subcontractor who is actually going to install this system on the field, he's going to be responsible for the system. We just give recommendations of how it should be installed in order to avoid any clashes in the field. So you might see, even on this resolution, that in this example we have a duct system on the screen, and we just annotate all the important pieces of information, like top of the duct, bottom of the duct, the sizes, the certain distances from grid lines, and so on. Obviously, in order to be able to carry out such a service, we have to have all the subcontractors bought into it. So we do want to coordinate not only one system, not only the ducts, but we can only be successful if we coordinate all the other systems around it, so all the gravity pipes, all the pressure pipes, fire protection, electrical systems, and so on. Another bulletin point is virtual mockup, and this is a really successful project of ours, so let me talk about it 1 or 2 minutes. And it's an answer for another previous question about ROI, return of investment. We worked with a Californian owner. It was a hospital, St. Joseph Health System, and they had this crazy kind of facade. It's really complicated because all the exterior steel bracings are covered with metal panels. And these metal panels are prefabricated with special color and so on, and they have to fit on the building perfectly. So they asked us to create such detailed models, and as you can see, probably it's more detailed than what you expect from a building information model. We also modeled the studs, as you can see on the left image. On the right image, you may see a beam which is having fire protection around. So it's really, really detailed. And we modeled all the individual metal panels one by one based on shop drawings, and we just put them on the building as it would be happening on site. So we found out during the exercise that approximately 50% of the metal panels that we modeled were wrong, and actually at that point we had to stop the construction because it was already an ongoing construction. So the owner decided to stop the construction for a while and redesign these metal panels, because otherwise it's just going to be a failure. And the good thing is, and now this is the answer of ROI, the owner give a publication about the numbers, how much we saved them with this service, and it was $2 million that we managed to save them by not having to reorder all the prefabricated metal panels and all the delays that it would have caused. So it's a pretty successful story. We also do consulting and production controlling, for example, as you can see in the last bulletin point. I will talk about it later as well. Well, this is just an image about one of our ongoing constructions in Oakland on a hospital. You can see that we are on site, and they found our service that valuable that they put it on their beam, on their last beam that they install on field, and Vico software is going to stand or going to be on this beam. So let me talk about the application a bit as well, because as I said, it's really important to understand how the application works, just in a nutshell, to be able to really talk about my topic, which would be planning and managing the huge flow and huge amount of data. of building information models. So this is trying to be a globe which represents a life cycle, or not an entire life cycle, but at least the designing and construction phase of a building. You cannot see, I think, the terms, so let me just read them. There is explore, plan, control, and manage. So this stands for the different phases of the construction and pre-construction. And on the segments of this globe, you can see different kind of issues that usually are occurring on constructions, on projects. So let me start from the first one, which is 2D documentation. Even though we are talking about advanced technology now, this time in this presentation, we are still in the 2D world. So the buildings are being built based on 2D documentation. As the documents are being developed over time, over the 3 years of planning or even more, there are different drawing releases, different phases, and the architects, and not only the architects, I don't want to blame the architects, but the designers may forget to show the changes. So they just give a new drawing release, and good luck finding out what the changes are compared to the previous one. So what we do as a service, and also we develop the technology for it, we overlay these documents and automatically find the differences. So now it's much more easier to find whether this new building is going to work, I mean, let's say for coordination purposes, or you know where to focus if you want to do a new estimate of your building. 3D clash detection and constructability. I already talked about it briefly. So once we have the 2D documents, we know what to work from. We can really build our model, and even in the application, we have a 3D clash detection tool as well as nowadays. I think it's a pretty famous topic. Constructability analysis, as I said, you can do that yourself as a designer. You can do that as a consultant, as we are doing as a services as well. So as we build the model, we find the issues, and we just report all these difficulties. The software is capable of doing that. RFI stands here as well, request for information. All our constructability issues that we find, or most of them, are going to be turned into real RFIs in field, and the owner, the general contractor, will find the responsible designer for answering those issues. So let's assume that after 3D modeling, we really have a model to step on, to move on. And in the VICO, we usually talk about 5D BIM. So let me introduce the fourth and the fifth dimension to building information modeling. Fourth is the scheduling. So we have the quantities coming from the exact quantities coming from the 3D model, as exact as we make them, as we accurately model. And by adding some productivity rates, so for example, we know how fast 1 cubic meter of a concrete can be poured. Adding that to our concrete volumes in the model, we will have the schedule. There is production control as well. Please remember for that, because I will come back to that topic later. Scheduling will be done in a location-based theory, so not the entire construction is going to be done in one phase. We have lots of different phases, even systems. So for example, the exterior facade is going to be done in a different location breakdown than our foundation system. So that's the fourth, the time aspect of the 5D BIM. And the fifth is adding some cost, some dollars, some euro values to it. So once we know the exact duration of our construction, and in the fourth D, we can add some unit rates, some human unit rates, resource rates, and also we know the quantities from the model, so we can just quantify and add some unit rates to, for example, our concrete volume as well. And in the end, we will have a real cost plan. In the middle, you might see Office, so that's our product, VICO Office, and you can see that we are trying to utilize as many different sources as possible. Revit and Archicad, those were the starting points, and especially VICO started out from Graphisoft, so Archicad is obvious. Revit is widely used. I think that's one of the biggest modeling applications in the world nowadays. We are happy to have direct connection with Tekla as well, but to get around any kind of translation issues, we are utilizing 3D DWG and IFC as well. So we try to make all the different kind of modeling applications work in VICO Office. So you can just publish your models into VICO Office and start your 4D, 5D, or clash analysis in VICO Office. Let's see the 5D workflow with a simple example first. And it will give you an understanding about how detailed a model has to be. And that's going to be the second part of my presentation, detail, level of detail. So this is the first example for that. This is a column, and as you can imagine, a concrete column is not only a simple box, but it has multiple aspects to it. It has different systems inside the column. However, we don't want to model all those. If we have this simple geometry, we will use the quantities to quantify the different aspects of a column. So, for example, if you take the volume, we can quantify and we can calculate how much concrete we will need to pour this concrete column. If we use the same volume and some factors and knowing how much percentage of a concrete column is a rebar, for example, and knowing the density, so a couple of small factors, but from the same net volume you will be able to calculate the rebar, even without modeling the rebar. In some certain cases you would model the rebar, but for the first quantity takeoffs you definitely don't need that. Well, for a concrete column, we need formwork as well, and the good news is that we have vertical surface areas, for example, that we can calculate from these simple shapes, from this simple box. And that vertical surface area will be used for calculating the formwork, calculating the cladding and surface finish, and so on. Once we have this formwork, so it is not modeled, it's just calculated in our cost calculation. Once we have the formwork, we know exactly how much material we need for that formwork, and adding the productivity factors that I mentioned previously, so knowing how fast we can build 1 square meter of a formwork, adding that factor to our quantity, we will know the necessary labor hours, so we can start our scheduling activities. And we might need some equipment as well. We can easily calculate from the formwork quantity. So I mentioned both the labor, we calculated the necessary man hours, and I also mentioned that we will have some locations, because, for example, pouring a foundation will happen in very many different locations. We will create the location breakdown structure, the LBS, that's what LBS stands for. And right after that, we will go to our scheduling application, which I will talk about a bit, because I'm not sure how familiar you are with the cyclogram, what we call flow line theory of scheduling. I will spend some time on describing that. Once we have it, we will have all the different options for analyzing our project. So cash flow, procurement, resource needs, and so on. We can create all different nice graphs and charts that needs for a successful project execution. Even though it's not going to be a software training, let me introduce 2 terms, because we will need them for going on. One of them is TOI, takeoff item. So it's a group of elements that the user can define. And these elements in the group are similar from a certain perspective. And the user will define what the similarity is. So to give you a couple of examples and to better understand, if you want to have all your columns in the building as one group, you can do that. You will just call them columns. If you want to separate the steel and the concrete columns, for example, you will have 2 different takeoff items. One is the concrete column, the other is the steel column. If you want to differentiate them based on size as well, you will have, let's say, 30 by 30 and 50 by 50 columns. So you will have multiple takeoff items in your calculation. And you can make it as detailed as necessary for the project. So, for example, if the columns are having different type of rebar in them, you can differentiate the columns by rebar type as well. And why would you do that, the question is? Because of the second term, which is the TOQ, the takeoff quantity. So you can quantify these group of elements, these takeoff items together, and you can calculate, for example, the net volume of the similar kind of concrete together. And that's going to be really important later on. So, Vico Office is an integrated solution. It means that starting from the 3D model, we add our scheduling and estimating portion to it. And whenever you change something in the database, whenever you change something, let's say in the 3D model, you have a new design, you have an updated design, you change something in your column layout, you can import the new model, and it will automatically update your schedule and your estimate. Just like if you work on your schedule, you optimize it, you make the duration shorter or longer, it will affect your estimate, and it will automatically update your estimate. Let me talk about 3D models just for a second. I already mentioned the different kind of software applications that we can use for 3D modeling. And we know that, probably that's an answer for responsibility again, so not all the designers are working in the same applications and in the same pace, and that's perfect. We just want them to work as they do. The only thing that they have to do is to publish their models on a frequent basis as the project agrees into Vico Office. So in this example, you can see that, let's assume, even though all these screenshots are from Revit now, but let's assume that the structure was put together in Tekla by the structural designer. Let's assume that ArchiCAD or Revit was used for the exterior design, and some kind of CAD application was used for the MEP systems. All these can be imported, all these can be as separate models in the Vico Office environment. So once a new update is available only for the structure, it will affect only the structure, nothing else. So we will update only the structural model. As in the previous slide you saw, it's going to update our schedule and estimate automatically. An example of how such a model can look like, in this case, the foundation is kind of detailed, so we know already that it's going to be a deep foundation, we will have some piles and so on. But the architectural design is just lagging behind, as we can see. It's only a mass representation of the building so far. And the reason why I'm showing you these images, because this is when you activate the models in Vico Office, this is when you choose which model version and which models you want to work with. And when you activate the models, that's when you really decide how to combine these different elements together, how to create the takeoff items. And it's not a rocket science to create these takeoff items. You don't have to be a really advanced user. You don't have to dig into the properties of the different elements. The takeoff items are pretty much generated only by name. So if you talk about ArchiCAD, we use 3 properties: the element type, the layer, and the ID. If you talk about Revit, that's the same. Family type, family, and mark. So you can imagine that in case of ArchiCAD, for example, you put all your columns on a column layer, and you just differentiate all of them based on the ID. So you will have column on the column layer, and 30 by 30, 50 by 50, 60 by 60 in the ID field. Then you can decide how you want to activate them, what kind of information, what level of richness you want to have in your project. Once you did this activation, this is the next step that you are going to see. You have some foundation elements showing up in the 3D window. And on the left side, you see the list of your takeoff items. So again, the group of elements which are behaving similarly, which are similar from a certain perspective. So around in the middle of the screen, you can see the CIP pad footing. So the custom-place pad footing, for example, you can see that it has 7 different versions from F1 to F6, and we also have one which is called ID. So these are the takeoff items. You can quantify them. You can go on with the cost calculation of these takeoff items. On the top, you see one takeoff item opened up, let's say. There is a small arrow on the left side, which is responsible. If you click on that, it will open up all the available takeoff quantities. So now you can see that in case of a continuous footing, for example, you have length information that can be quite important for laying out your continuous footing. You have net volume, surface areas, and so on. So you can use these quantities for cost calculations. Let's see an example for a slab, because all the different modeling tools are behaving differently, not only in the modeling application, but also in Vico Office. So to give an example, a column has a height, while a slab does not have a height. It has a width instead. A wall has a length. A slab does not have a length. So different behaviors, you have to keep an eye on them. You have to know when you are modeling and you are planning your project. Just really quick, a couple of examples. So a slab has a width, as I mentioned. It has a perimeter area, a whole surface area, net, top, and bottom surface area. Net volume, for example, or that's the gross volume, but we have net volume as well. Surface areas, different kind of surface areas, and so on. These are the quantities, the takeoff quantities that we can use for calculations. And in this slide, you see the actual calculation. So this is a custom view now. In Vico Office, you can build up very many different custom views as you like. On the top, you see the 3D model again. It's not a complex 3D model. It's just 2 slabs. On the right side, you see the available takeoff items, and together with them, the available takeoff quantities. And on the bottom, you see an Excel-like, spreadsheet-like view, which is actually your cost plan. So our cost calculation happens pretty much in an Excel, because our developers found out that in Excel, you can calculate everything that you want. So we did want to have this flexibility, and that's why we decided that it's just going to be a spreadsheet where we do our calculations. But with this representation that you can see on the screen now, you can tell what kind of quantity or what kind of element you are quantifying right now, what do you want to calculate or estimate the cost from. And that's highlighted with a yellow color. You will see exactly in the list of takeoff items, in the list of takeoff quantities as well, what you are using for this calculation, as well as in the 3D view with this beautiful magenta color, it will show you what you are using for quantity calculations. And that gives you a huge opportunity for transparency, because if you are sitting in a meeting with estimators, with owners, with all designers, whoever is responsible or involved in the given phase, you will clearly communicate to them how you quantified certain elements and what gives you the cost calculation. That's another custom view. I'm not going to spend too much time on it. The only thing that I want to show you, if you have such a database already built up, or if you build up your database as you start working with Vico Office, you will have some cost line items, and these cost line items can easily be linked to the 3D model with entering some formulas, or actually you don't even have to enter formulas, because it's going to be a visual connection between your 3D model and the cost database. If you have such a cost database, you will be able to reuse it from time to time and make it richer, and add more and more information to it from project to project. Let me talk about evolutionary estimating a bit. So this is a theory that is also supported by our application, and I may mention that I would like you to remember that we are not doing only 5D cost planning, but also cost controlling. And this is the slide for that. So in the very beginning, we do believe that BIM can be used in very early design phases as well. So let's assume in the very beginning that we only know that we are going to build a hospital somewhere. From a modeling perspective, it's not a huge challenge. We will just build a mass model. But this mass model can be used for taking off certain quantities, like surface areas for the exterior facade, like net volume for certain reasons, and so on. So we can already start quantifying and already start adding cost information to our model. If you go on, in a certain phase, probably you will know a program layout, so you will know exactly that how many square meters of surgery you need in the hospital, how many square meters of corridors you will have in the hospital. So you can start building your mass model, detailing out your mass model accordingly, and start doing a more detailed quantity takeoff and a more accurate cost calculation, because surgery is probably more expensive than a corridor. If you go on in the middle of the screen, probably you will know the site conditions, for example. So you will know if you have to have a shallow foundation or a deep foundation. You can start modeling that, not knowing yet the exact sizes of the foundation, but knowing the type of the foundation. So you can assign averages, for example, or typical prices to these modeling elements. The good news is that you can always save a snapshot of these cost calculations, and you will always be able to compare back your actual project to the first project, which is probably the target. So at the level of detail 200, which is around in the middle, let's say you can always compare back to the very, very first mass model, which is the target price of your project, and see whether you are on track or not. What can happen, for example, is your foundation got way too expensive because of certain soil conditions. You cannot do anything with that. The only thing that you can do, and this is really how we want to control the projects, that you have to make the painful decision probably to get rid of the metal panel, and instead of that use a cheaper surface in the exterior scheme. I mentioned flow line, cyclogram, and 4D scheduling, so let me jump into the 4D scheduling a bit. And let me introduce you our way of scheduling. So it's going to be a bit different from the standard, the traditional Gantt scheduling, because we added one more layer to it. Actually, not us, it's a theory, so this is how cyclogram works. On the top, you see the calendar, the time passing by, and on the left, you see not the names of the tasks, but a location breakdown structure that I already mentioned. And in this representation, the tasks are going to be these diagonal lines, and it gives you an advantage to see how the tasks are flowing, how the groups and teams crews are floating from one floor to another, from one location to another. So in this example, you can see that on the last week of February, the plasterboard walls, so that task as well as that group, should be working on the second floor of the second building. While on the same day, on the second floor of the first building, we should be already working on finishing these plasterboards. The good news is, there is lots of chance to analyze this picture. So for example, we can see if there is somewhere a huge gap where there is no work performed, if there are some opportunities to make the work more efficient. And also you can tell if some tasks are contradicting, or in the same locations you would be having, let's say, an HVAC installation while you would also be having a drywall installation. That just doesn't make sense. You will not have enough room for your crews to be able to work in the same location. But the easier to understand is to identify these huge white areas, which now I represent with a yellow color. You can see that on the first floor, there is 3 weeks where there is no work performed. There is no way that you would find out the same in a Gantt schedule, but now it is really easy to see in this representation that in this white area there is no work performed. That's not the most efficient. This is when we start optimizing the schedule and try to make something happening in that location as well. So let's start from a Gantt view this time and transform the traditional way of scheduling into a flow line representation. And this is something how it would look like. So it is easy to identify, again, these white areas, and you see that there are huge durations where there is no work performed in certain areas of the building. What we want to do in these cases to make them parallel, and that will mean that the work is continuous and also as efficient as it can be. You may see the duration of the original project, that's duration A, and you see duration B, which is a significant difference. I can do anything in the presentation, obviously, so I could make even a better result in this presentation. But we have historical data behind us, and it says that from 10 to 20% we can reduce the overall construction duration with this methodology. A different example from the same situation. So now we have on the left side the location breakdown again, on the horizontal axis the time passing by, and now you see some kind of tasks being built up. We will easily identify the white area again, but there is another issue that's occurring in this example that we want to avoid, and that's the start and stops. So we have this tiling task, and you can see that it's a pretty fast task. So in one location, in one floor, they only have to work 2 or 3 days or something like that. But because of not having predecessor locations, not having the next location where they could be moving and working on, they just have to leave the site. And that's not efficient because every time they arrive, they do some preparation. Every time when they leave, they have to clean up the site behind them. So they have some additional tasks that they have to carry out if the task is not continuous. Also, if they leave the site, they want to do profit on these other days somewhere in another project as well. So they are going to work in another project. And sooner or later, rather sooner, I guess, they will not come back to our project on time, and that's just going to pretty much ruin the entire construction. So what we want to do in case of optimization, to make these parallel, or that will come later, to make this continuous. So now you see that the tiling task is now continuous. For now, I added a new waste area, but don't worry about that. I'm going to remove that in the next step when I'm trying to make these tasks parallel. Obviously, in a real project, it's a huge effort, and the negotiations with the subcontractors, how you can finally reach this position. You can see a decent save in time again, but we are not going to stop here. we also want to reduce the risk on the project. So in order to reduce the risk on the project, we will add some time, some buffer lag to the project again, which means that we calculate with some uncertainties on the project. We calculate that something is going to go wrong on the project. That always happens. We run into wrong weather conditions, a more complicated area or something like that. So let's just give some allowance for that and give some buffer time. You still see that we saved 3 weeks in the schedule. So that was the planning, and we go on to construction. Because if you remember, we are not only talking about cost planning, but cost controlling as well. We are not only talking about schedule planning, but schedule controlling, production controlling as well. So what we do is to go out on site on a frequent basis, let's say on a weekly basis, and just check how the different crews are performing. So you can see that the framer on the first floor is finished. There's a check mark there. Then the second floor, they are finished. The third floor, they are finished. They are progressing pretty well, I guess. Then they are working now on the first floor of the B building. And with the color code, we can see that the 45% that they achieved is pretty good. Let's see the drywall. They completed the first location, but something is wrong on the second location because, as you can see, during the site review, you found that they completed much less than what you wanted them to complete. Not to mention tiling, which is way behind. So let's see how it is going to be represented in the flow line view. Let's assume that January, the last Friday, was the review meeting, and you see that the framer is a bit behind, but that's okay. Not as the drywall. At that point, they will say that no worries, it's just 2 days. But you will see, as the application will forecast you based on the actual completions, you will see that if they are progressing this way, that's going to be 6 weeks of delay in the end if they don't do some changes to their work. So that's a new negotiation again, what you can do, what the subcontractor can do to get back on track and to control the project. And in this example, what we are going to do is to add one more crew to our project. So instead of working with one crew only, it's going to be 2 crews. Obviously, the more the resources, the faster not the faster, but the shorter duration they can carry out the construction. Because of having the buffer that I just mentioned, which is responsible for reducing the risk in our project, you see that in the end, even though we had some certain delays during the project, in the end, most likely they will end up in the desired date and not going to screw up our entire project. So this first half of the presentation was about showing a couple of examples of what we can achieve with BIM, what we can achieve with the help of Vico Office in some cases. But if we are not controlling all these opportunities, we are going to end up with a project failure. So in this next in the next slides, I'm going to talk about how you can plan and how you can manage this huge amount of data. So model progression specification. This is the solution that we believe is going to help the industry, help the building information models to be well designed, well planned, and also to be managed to the target. Just a note, model, it's again not meaning 3D model, it means the BIM model, which in our case is a 5D model in this example, but you can go on and rethink what you want to include in your building information model. So the 5D is the 3D geometry, the cost, and the time aspect of a model, but you could be adding FM if you wanted to. You can add energy simulation and calculation if it's necessary. So the MPS is really just a framework which will tell you how your model should be progressing from the very early phases to the final as-built conditions. It defines how the different systems should be developing from time to time, so how your structural design, how your architectural design, and MEP design should be developed over time. It's a planning tool, so we have to plan it ahead of starting the construction, starting the project. But it's also a management tool, so we can measure whether we achieved the certain goals that we set for ourselves. And we hope that this is going to help, as I mentioned, to enjoy all the benefits of a BIM model. So let's see a couple of issues that may occur during a project. Modeling issue. In the first example, if you model steel columns, how do you want to model these steel columns? Do you want to model floor by floor, or do you want to model from the foundation to the top roof? That's two different scenarios, and both of them can be good. But you have to communicate it, you have to record it, because when an estimator wants to quantify how much steel, for example, we need, he has to know how you modeled it. It's important to note that the estimator and the scheduler and the BIM modeler team is going to be different departments of a company. It's going to be different people, so the information flow requires all these details to be communicated from the very beginning. As another example, maybe in the early design phases it's enough if you place a 2D representation for a door. You can quantify even that. You can really count how many doors you will have in the building. But as the design develops, you may want to calculate the surfaces, because you will have a special kind of surface in some doors. You have some security doors and you need the surface for that, and so on. Other examples, but I will be quick as much as possible. That's a typical scenario in concrete structures. Let's assume it's a foundation, this time a continuous footing. I represented two different ways of modeling it. You have to decide how you want to model it. Both options can be good. So do you want to model the continuous footing with this entire section? Or do you want rather the slab on grade next to it to reach the exterior perimeter of the continuous footing? Both options can be good. Actually, they can even be overlapping if you want to. The only thing that you have to do is to communicate to the estimator, because they will have to apply different factors to them. As well as in this case, this small triangle, it happens, you can find them all around in the building. How do you want to quantify them? You can simply do that in the middle somehow, so do an average and this easy and faster modeling tip. So you can model this way. That will give you probably the good quantities. But if you want to use the model for coordination as well, it's probably not the best solution. Another solution is to be on the safe side. And this is really good for coordination, because you can make sure that there are not going to be any ducts, any pipes running in the modeled area. But this is going to be wrong for estimating. Or not wrong, let me rephrase. The estimator has to know that he has to apply a certain factor to your model, because you modeled the concrete structure bigger than it should be. Let's see the next problem. So with building information modeling, very many intermediate releases can happen during a project. So as the design evolves from the very many different disciplines, from structural design to architectural and MEP design, as a construction manager, as a virtual or a BIM champion, you will just be overloaded with the information. And if you don't manage it, you are going to end up with a failure. So the message is that you have to know all the times during the project execution what you want to focus on. If it's, let's say, time for the foundation, you want to focus on for pouring the foundation. You want to focus on the foundation only, and you don't really care about the MEP systems of the superstructure and so on. In this slide, we represent a problem that some areas of the building are being developed faster than other areas. So there are some places which are just much easier to design than other places, or some systems can develop faster than others, which is not a problem. You just, again, have to know how your project is being executed. And as globalization is getting bigger and bigger all the time, we can see that the project teams are not being necessarily chosen by location, but maybe based on expertise. So it can happen that on one project, there are very many different designers working from different regions of the world. Again, communication is really important. So, after all these problems, after all these opportunities, we do believe that we have to have a plan in place that we can follow, and that we can deviate from at least, in order to have a successful project execution. And this is what we call a model progression specification. So we want to add, we want to give a tool into the hands of our customers. And this tool is model progression specification again, or as we call it, is a 5D data pack. So let's see in this slide what a possible implementation of a new technology can be in a company. Let's start from the sales presentations. When the salespeople come to the company, they give the best view of the new application of the new technology. And maybe the company gets bought into it, and they decide that this is going to solve all our pain, all our issues. And this is the way where we want to head to. Then, as they start using it and start seeing how the certain application or technology or theory works, they may end up in an informed doubt. It means that they see that it does do certain things, but on the other hand, it doesn't do what we expected. At that point, there is a huge risk of the total loss of confidence. So we may lose the company who is willing to go towards BIM if we just don't help them. So that's why we try to help them, and that's why we give this 5D data pack, this model progression specification, to help them go through the early weeks, early months of implementation, and to end up with a realistic concern when they can document what they know, what they are starting out from, and where they want to end up. And hopefully, that will help them to reach the informed certainty. Again, the 5D data pack and the model progression specification, this is what I'm talking about now. And the good representation to it, to understand what this data pack is Lego. So the beautiful thing with Lego is that you open up a box, and with these different shapes, you can build all the nice structures that you want to. And also, as you open up the box, you will have some specifications that gives more layers, more content to your Lego structure. So we wanted to do the same with our virtual buildings, and this is why we created these, what we call virtual warehouses, our virtual Lego boxes. And as you can see, we predefined a couple of certain elements that you can use during a certain stage, certain phase of your project for modeling. And this is not only a 3D geometry. If you remember the very beginning of my presentation, the way how you link your cost database, which can be reused from time to time, you link it to your 3D elements based only on naming. So if you have a certain and strict naming convention, you will be able to automatically create the 5D estimate and the 4D schedule from your 3D model. So this is why we defined these elements. These are predefined geometries that you can use, customize for projects. But it also carries not only the 3D information, but already through naming, the schedule and cost information. Obviously, it has to be linked to our database, which is predefined probably. Let's see a brief history of what we've worked over the years. Actually, since Vico exists, I think we work on model progression specification. We ended up now in the 3.0. It seems now that we are finally on a good path, but we started out from, obviously, MPS 1.0 and 2.0. I will be as quick as possible. This is now what you can see is the first tries for defining how a model should be behaving over time. So on the left side, you can see the different disciplines of a project, the different systems. So you have substructure, superstructure, site preparation, and so on. On the horizontal axis, as usual, you can see the time passing by. In this case, it's not days or weeks or months, but stages. And the stages have to be defined by the project team. We recommend that these stages would be really frequent. A couple of weeks probably would be good enough. Not the traditional phases of schematic design and design development, construction documentation, and so on, because there is just too huge time in between these releases, and too many things are happening in between these releases. So if the architect is designing the building for 3 months, and only after that we start calculating the cost of the new design, that's probably going to delay the project, and you will not be able to control your costs any longer. It's much better to release in smaller stages, in more frequent stages. And with these numbers, these are the LOD, level of detail, or level of development numbers. running numbers from 100 to 200, 600 as the project team defines. So with these numbers, you can represent how developed a certain system has to be. In this example, stage 3, it's an early design phase. You can see that substructure, superstructure, and exterior should be designed to a 200 level. But for example, we don't really care about site preparation yet. So that was the first try. And then the second phase of MPS, model progression specification, we found out that one number cannot define an entire project. So we started to add more layers to it, and that's what we call aspects. So we started to add the modeling aspect, the estimating aspect, and the scheduling aspect, which is not even on the screen. And we started to define classes to these aspects. So now you can see, to go back to the level of detail 200 example, that we will need a model which is developed to the second class, so building elements with approximate dimensions. So in level of detail 200, we also need an estimate, which is an E3 estimate in this case. It's an element-driven and assumption-based estimate. So it means that, and also cost ranges, that's pretty important. So it means that our project is not really defined yet. We don't know the exact sizes of the elements. It also means that we cannot put a 100% accurate cost estimate, but we can really define the ranges where we will end up after our project. And it also carries scheduling information, obviously. So what we did during this MPS 2.0 effort is to define all the different kind of elements which can occur in a construction. So timber slabs, from precast foundation to cast-in-place foundation, steel elements, and so on. Lots of pieces of information and huge amount of data was analyzed, and we defined all the different behaviors of these elements. And this tree represents what we did. We ended up in the end of the branches where the leaves should be, and it's just, you can imagine that it's not manageable, it's not usable at all. We ended up with a huge book of thousands of pages defining all these elements, how they should be behaving and developing over time. Once we found out that this is not the right path, we stepped one step back and tried to find the similarities in between these elements. And this is when we introduced now the MPS 3.0, the primitives. So we found out that there is not really a value in defining how a timber slab should be working as opposed to how a concrete slab is working, because from a modeling aspect, from an estimating and scheduling aspect, those are the same. It's just a different material, but those are the same. So we rather define these primitives. I will show you a couple of examples for these primitives. And as you can see in our Lego box, these primitives are already carrying this cost and scheduling information. So for example, the primitives of solid elements, we have walls, columns, beams, slabs, and pitched roofs. So it's pretty easy to count these. Actually, that's only 5 different kind of elements. No matter if the wall is, let's say, a precast concrete wall, or a cast-in-place concrete wall, or a masonry wall, we are going to handle it in the same way. And it's going to help us reducing the documentation that we have to do and what we have to follow. If, in certain cases, you decide that your project is developed enough and you see value in modeling the masonry wall brick by brick, you can do that. The only thing that will happen is that you have to apply the same rules of modeling these blocks that you would apply to the entire wall. So the same rules are applying, it's just in smaller pieces. I just ran through really quick this because we ended up in the Lego box that we wanted to achieve with the modeling, estimating, and scheduling content. I think this is much more interesting and will describe the situation better. So on the top, again, you see the development of the project. You see from LOD, level of detail, 200 to 600 or 500 in this example. And on the vertical axis, you see the different aspects of our 5D model. So you see on the top the 3D representation, the geometry, how it should look like over time. Then below that, you see the estimating aspect of that, and below that, the scheduling aspect. So if you take an example of an LOD 200 model, you remember it requires an M2 model, and that M2 model is not a really detailed model. It means that we only differentiate the walls, for example. Yeah, we took the wall as an example. So we only differentiate the walls based on material and construction method. So we will differentiate the concrete from the timber, but that's it. But we use only one type and one size. So if we have a wall from 10 centimeters to 12 centimeters, we are not going to differentiate them. That's going to be the same, and we can link our average cost information to it. As we go on, you will see these blue cells. Those are representing the changes from one level of detail to another, so as the project is being developed. So now you can see that, for example, from a modeling perspective, M3 model on level of detail 300, now we are differentiating our different elements based on thickness as well, based on the schedules that we were given. So it gives us the opportunity for a better coordination, a better estimating and scheduling, and so on. Probably it represents even better, or the next slide will be the best. So now you can see that in the first case, that's an M2 model, let's assume, we only have one type of wall. In the second M3 type of model, we will differentiate by thickness as well. And in the M3 model, we will also start adding small details like penetrations. We could not do that earlier because at that point, probably in the project, our MEP systems are not coordinated at all, so there is no way that you can place the penetrations in the right locations. The same with the slabs. So now you see that we start out from one slab, but in the end, as the project is being developed, we will exactly know if it's a precast concrete slab or a cast-in-place concrete slab, what kind of systems we chose. I'm trying to speed up a bit because I think I'm late. So this is a matrix, an example of how this should be really working. There is not only one solution. It always has to define project by project by the project teams. But in this example, you see that, for example, as you reach the stage 4, you accept to end up with a level of detail 200 in case of certain elements. And for all stages, you can build up your Lego box. So you will have all the cost, design, and scheduling information. So pretty much you just have to put together the model, the 3D model. How you use it in projects. So let's start with planning first. Lay out what you want to achieve during the entire execution. What are the certain goals of the project on a certain stage. Then during the next step, once the design is put together, let's evaluate, let's actually do the modeling and do the scheduling and estimating portion of our 5D model. And in the last stage, really check what was done. If the goal was to have all the penetrations in our model, you can easily check whether they were really modeled into your model or not. And obviously, you can finding the differences, and you can plan the next stage, what you really have to achieve for next. Really briefly, for each stage, we are not only creating a 5D data pack, which is a 3D model containing all the information, but it's good to have such a simple Excel spreadsheet going with it, which describes how the elements are behaving. So for example, in this case of a pile cap, you see that we will name them in a certain way. We are using a classification system, but I don't want to go into that. So in a family type, we will give a certain name to our elements. In the mark field, we will give a certain differentiation of these elements, so type 1, type 2, and so on. It will generate our takeoff items. If you remember the beginning of the presentation, the groups of elements which are behaving similarly. And you can see the listed aspects of this 5D model. So what you can expect from the 3D model, how you can quantify it, and how you can put together your schedule. To summarize, I'm not going to summarize everything. This is now some short descriptions of what we discussed. So from stages, you remember those are intermediate time frames of meetings or discussions or decision points during the phases. Aspects like what you want to include in your model. So it's, if it's scheduling, estimating, or FM or energy simulation, and so on. Level of detail, this is the huge matrix that defines how your entire project should be developing over time. primitives are the 3D geometry, which are behaving similarly, and so on. If you want to achieve, and I think that's the goal, that's the overall goal, if you want to achieve automatization or an automatic project execution, this is the tool that we recommend you to use. This is being defined by us now, so we are going to share it with you as much as possible. So it's not the one tool, I still believe. This is just a good recommendation that we have been working on for 5 or 6 years now. So you rather take this opportunity to start using our data and to start building your project based on our data. And if you need that, just shoot me an email, because we can put you in our email list, and we will send out not this presentation, but the actual work that we performed, the model progression specification, in a PDF format pretty quickly. So if you are on the list, not only you will be getting the PDF format, but also you will have access to our online resources. We have lots of tutorials and videos that you can enjoy and get into BIM more and more.
Köszönöm Akusele.
Köszönöm.
Et panin teie keele proovile, et kõik, kes teavad, et siis ungari keel on tegelikult sugulaskeel. Köszönöm tähendab siis aitäh. Nii, aga kiired küsimused, kuna lõuna on kohe peale tulemas, tegelikult oleme juba 10 minutit üle läinud, siis kiired paar küsimust ja siis läheks juba sööma. Aga ma arvan, et lõpetame hetkel ära. Kõigepealt siis ütleks võib-olla nii palju, et tasulised kuulajad olete jälle oodatud 4. korrusele. Seal teile siis serveeritakse suppi, ma arvan, ja ka midagi muud, ehk mis siin kokkulepped on, ma ei tea täpselt. Ning siis 6 inimest, kes said juba tunnistuse kätte, palun tulge korraks registreerimislaua juurde tagasi, et paneme ka sinna allkirjad peale, et oleks ka selle mingisugune väärtus. Aitäh! Ja näeme juba tunni aja pärast.
Allkirja paneb vastne magister, nii et paberi väärtus suureneb. Ja üliõppilased, nii-öelda väljast üliõppilased, all söökla on teie käsutuses, sinna palume ka meie esinejad. Aga kui ma siit kasutan oma arvutist,